All right. Okay, I guess I'm a little early, right? It's only 10:29. All right, how you guys doing? Hope everybody's doing okay. You're not going too crazy inside the house. I know I am a little bit. At least I got to get out of the house this morning. I drove my wife to work. And just a quick update. So they're screening the nurses now when they come into work. They want to make sure that they're not sick. So they check their temperatures before they get to go into work. So that's crazy, right? But anyway, just had a chance. I've caught up on some shows. I just rented a movie yesterday. Vibing out here, 20th day, staying inside. It feels like the 20th day. What's crazy, it's only been like 9 days. That's the craziest part. But all right, okay, I'm gonna get started then. It's not a very difficult lesson, but it does get a little tricky. So let's get started, and we'll finish up early, and you'll have some time to hang out. Before I get started, are there any questions on the homework from the previous homework that anybody would like me to go over? Okay, if there's no questions, then we can just jump into the lesson. But if there are a few, we can take care of those first. All right, number 20. Let's go ahead. Let's take a look. All right. All right. Okay, number 20. All right. Looks a little tough. Let's take a look. Let me open up a new scratch paper here. Okay, so on number 20, I believe it was negative square root of 21 over square root of negative 35. Okay, yeah, it was. All right, so you see the negative is like they place it in the middle, right? So that could be the tricky part. If you ever see a negative placed in the middle of the fraction, just push it up to the numerator. Okay, so really that just means negative square root of 21 all over square root of negative 35. That's all it means, okay? All right, well, from here, all right, let's take a look at 21 first of all. 21, the problem with it is that if you try to simplify it, you end up with the factors of 7 times 3, right? And then there's no other way to factor this any further. So square root of 21 is stuck as the square root of 21. But in the denominator, you have the square root of negative 35. Remember what we talked about last time, that if you have the square root of negative 35, this becomes the product of 35 times negative 1. Right? So then that allows you to split this as the square root of 35 times the square root of negative 1. So that becomes square root of 35 times I. Okay? All right, so at the very least, we can say negative square root of 21 all over square root of 35 I. Okay, now something else that might be kind of a creative way to deal with some things like this is let's say you have square root of 21, right? Because I'm not sure what the answer at the end of the sheet is, but I do know this, that the square root of 27 could also be the square root of 7 times the square root of 3. And I know that the square root of 35 is equal to the square root of 7 times the square root of 5. Okay, so what if we try doing that first, right? Well, what if we leave this as negative square root of 7 times square root of 3 all over square root of 7 times square root of 5 times I? Okay, do you see where I'm trying to get at? Now that I know that both of these have square root of 7s, these cancel each other out. Okay, at least for now. So then instead, here's what we're left with, something that's a little bit more simple. Okay, that we can manage a little bit easier. So now, using the reciprocal, I'm sorry, not reciprocal, the, what's the word I'm looking for? Rationalize. We want to rationalize. So you want to multiply, go ahead and multiply the top and the bottom by the square root of 5i all over square root of 5i. Okay, so then, right, now you have a negative square root of 15i in your numerator. And in your denominator, you're going to get the square root of 25i squared. So now, let's clean up. I got negative square root of 15i all over, well, square root of 25 is 5, and then I squared is negative, right? So now we end up with negative square root of 15i all over negative 5, okay? At the very least, I can at least cancel out the negatives that are on the outsides. So that leaves us with the square root of 15i all over 5, okay? So I'm not sure if that's the answer that they give. Okay, let me double check. Number 20. Yep, that's the one, right? The only difference is that they put I in the front. Again, I don't like that the book, well, at least that this book is doing that, because I is always supposed to be in the back, or at least after the number, not in the front. Okay, so I believe that's where they get the square root of 15. They probably did it in a different way, right? But rather than multiplying 35 times 21 and getting these huge numbers, there's always this kind of creative approach you can take by splitting up the factors of 21 as two separate ones, and then you can cancel out the ones you need. Okay, so that's pretty much it. Anything else from homework? All right, cool. Okay, so then let's go ahead, let's jump into the lesson then. If anything else comes up, then just let me know and we can go back. All right, so today we're going to take a little bit more time discussing the complex numbers. So I made a brief introduction to the complex numbers last time, just to remind you what we looked at. The complex numbers, remember, they take this form, a plus bi. Okay, so they have two parts and they're stuck together, making them complex. One part of the number is real, the other part of the number is imaginary. Last time we looked at the imaginary part of the complex number. Today we're going to look at both sides. Okay, so we're going to start off with some formal definitions about what a imaginary number is and what a complex number is. So to formalize it, an imaginary number, okay, is a number of the form a plus bi, where a equals 0, a does equal 0 and b does not equal 0. Okay, Why is it that that must be the case for an imaginary number? Well, an imaginary number, let me give you an example, would be something like 5i, right? That is an imaginary number. Why? Because the a part is missing, okay? You're only seeing the bi part. So if you only see the bi part, that's the imaginary number. Now, in this case, a has to equal 0 because a plus 5i is the same thing as 5i. I'm sorry, 0 plus 5i is 5i. So the real part of the number is 0, okay? Then the imaginary part of the number is represented by 5i, okay? So imaginary numbers, how many boxes? I believe today, 8. Okay, so that represents the imaginary, where a has to be 0 and b cannot be 0. Because if b was 0, imagine, you would have 0i. What is that? That's just 0. So then that's not an imaginary number, okay? So b cannot be 0. A has to be 0 for imaginary. Now, what about complex? Okay, a complex number has to include both parts. So it's a number of the form, again, it's still going to be a plus bi, okay, but this time where a and b are real numbers, okay, that just means a and b. The I is still there, okay, but whatever you plug in for a and for b are going to come from real numbers. Okay, so the number a, or actually let me do this. Okay, so the number a is the real part, and the number b is the imaginary part. Okay, which is what I mentioned earlier in the previous definition. So with a plus bi, you have a component. It's split into two. You have a real part and you have the imaginary part, and that's what makes it complex. Okay, you have a complex number, which is a combination of both real and imaginary numbers combined together. All right, so that's just some formal definition stuff, but it'll make more sense once we jump into the examples. And I meant 8 boxes, not 8 minutes. Okay. All right, so let's take a look now at a couple of examples. So before we jump in, here's kind of like the formal definition of a sum of complex numbers. Okay, so given, let's say you're given a plus bi, right, which is, let's say we'll call that complex number 1, plus another complex number, we're going to call this c plus di. Okay, how would you add these two numbers together, right? How would you add these two complex numbers together? Well, what you're allowed to do is you're allowed to add, because it's very much like combining like terms, you're allowed to add the real parts together, okay? And you're also allowed to add the imaginary parts together. Okay, so if I'm real, I can add it with real. And if I'm imaginary, I can add imaginary with imaginary. Okay, so in this case, here's how it works. I can then add a plus c together. Okay, plus I can also add the b plus the d together. Okay, why can I add those together? Because you want to think of I as like the like term, right? You want to think of I as if it was an x, right? They both share that same variable I. So then I can add b plus d. I can add those coefficients. Okay, so then I would end up with something like this, right? So imagine that we had actual numbers in there. We could actually add them together. Because right now they're just a bunch of variables, then we leave them like this. Okay, so let me give you an idea of what this means. Okay, so for this first example, Okay, given 4 minus 2i plus 3 minus 3i plus negative 4 plus 7i, right? So here I'm adding three complex numbers together. Notice how each complex number has a real part and an imaginary part, right? So I'm going to go through, I'm going to highlight each real part. Okay, so 4 is real, 3 is real, and negative 4 is real. Okay. Then my imaginary, that's represented by negative 2i, also negative 3i, and then positive 7i. Okay, so these are my imaginaries. So I get to combine them together, all right? So I get to simply take 4 plus 3 plus a negative 4, okay? If I add those three real numbers together, that's going to give me 4 plus 3, that's 7, 7 minus 4, back to 3. Okay, so I get 3. The imaginary components, I can add those together as well. Okay, so I'll negative 2 plus a negative 3 plus 7, right? So negative 2 plus negative 3, that's negative 5. And negative 5 plus 7, that goes back to positive 2i. Okay, and so then this is what we get as the new complex number from the sum of the other three. Notice that I'm treating I like if it was x, right? Same way that I would treat it like if it was 2x plus 5x, right? Though numbers, the coefficients can combine 7, but then those variables, we keep it the same, right? Very much like combining like terms. Okay, does that make sense? I believe that once you have numbers in place, I feel like it's pretty easy. Okay. All right. Any questions on that? Okay. Go ahead and drop them on the chat, and then I'll come back to it. Okay. So example number 2 now. Okay, something similar. Let's say we're given 3 minus 2i and minus 2 minus 3i. Okay, so now here you're given the subtraction, right? So it's a subtraction of a complex number. Before it was addition, so I could just add in between. When I have subtraction, I think the thing to be aware of is I need to distribute the negative the same way you would if it was a regular expression, right? Distribute the negative and then combine everything else after. So you have 3 minus 2i, negative times 2 is negative 2, negative times negative is positive 3i. Okay? Highlight the ones that are real. You have 3, you have negative 2, which are real. Negative 2i and positive 3i, those are imaginary. Okay? So you combine your reals, 3 minus 2, that's going to be 1. Negative 2i plus 3i, it's going to be a positive 1i. Okay? So you can simplify it even further if you want. You don't need the second number 1. You could just write it as 1 plus I if you choose. Okay? But this is also correct. Okay, so whichever one you prefer. Okay, so there's not much to it when it comes to adding and subtracting the complex numbers. They're pretty easy when the I is already outside, meaning that you don't have to extract anything like we did in the first lesson. Okay, so it's not too bad. Think of it as combining like terms. Okay. All right, let's move on. So now it'll get a little bit more challenging now. So for example 3, now we don't have the I given to us. We have to do some extraction. Okay, so we have to rewrite a couple of things. So let's say we're given, this, right? Now these count, right? These are still considered complex numbers because we know that eventually we have to extract the negative out of the square root and turn it into I, right? We have to turn it into the imaginary number. So start with the simple one, right? We know that here the extraction that takes place will create square root of 2 with the I outside, okay? And I can drop the 3. Minus, okay, now we got to do some scratch work here. Or actually, before we do that, let's go ahead and extract the I. So we keep the 50 inside, and the negative we get rid of the negative by writing I on the outside. Okay, now the first one, this one right here, not much we can do with that, okay, because the square root of 2 can't be simplified any further. However, the square root of 50 can. So we start with 50, we break this down into factors. We could say this is 10 times 5, and then 10 is 2 times 5. Okay, so remember that once you have factored it, those are no longer active, so you go ahead and cross them out. That leaves me with 2 times 5 times 5. What we're looking for is a pair, remember? We need a pair of numbers that we can extract. So if I extract a 5, that's going to put 5 on the outside, but since 2 doesn't have a pair, 2 goes back inside of the square root. Okay, so I can rewrite the square root of 50 as 5 square root of 2i, okay, and then I can bring down the rest, 3 square root of 2i. Okay, here's where this can become a little bit tricky. All right, you still have to think of these numbers, these whole numbers, as coefficients. Okay, these are your coefficients. Now, you can combine coefficients if they have the same term, right? Like if they had the same variable. Well, you got to check that they both have the same thing, right? So does the coefficient of 3, does it have a square root of 2 with I? Yes. Does the coefficient of 5, does it have a square root of 2 with I? Yes, it does. Okay, so I want you to think of this as basically being 3x minus 5x, right? Here, because they both have x, I'm allowed to combine the coefficients and make it negative 2x. So here, instead of it being x, you have to check to make sure that they both have square root of 2i. Okay? If they both have the same tail, right? The same tail, meaning like the thing that's in behind the coefficient, if they both have it as the same, then you can go ahead and combine these coefficients together. So 3 minus 5 would give you negative 2. Okay? The same way that here you would drop the x because that's what they had in common, you're going to drop what they have in common, which is the square root of 2i. Okay, that will not change. Okay, that does not change. Okay, so here this ends up giving us this as the final solution. Okay, so notice that this is only imaginary, right? There was no real component to this number, right? There is no a, right? It's all just a bunch. It's just a bunch of b. That's it. Okay, think of this as your b is equal to the negative 2 root 2. Okay, that is a real number. Okay, because if you were to type that into a calculator, you get a decimal. Okay, what makes it imaginary is then the I is sticking behind it. Okay, in this case, a would be 0, right? There is no a there. So it's a complex number, but it's just imaginary. Okay. All right. Any questions on that? Okay, drop it on the chat and I'll try to come back to it. Okay, let's take a look at another one very similar. Okay, so if the first example was a little bit challenging, let's try one more. Why did I combine the 3 and the 5? The 3 and the 5 are the coefficients. I can combine coefficients if they have the same variable, right, when we're combining like term. So I want to bring you back to this, right? If I had 3x minus 5x, I'm allowed to combine 3 and 5, right? Those coefficients can combine as long as they have the same variable. The same idea applies here, okay? With the 3 and the 5, I'm treating those as coefficients. And then I'm treating this part, the square root of 2i, as one big variable, right? Because they're both the same, right? They both have square root of 2i. Then that means that you can combine the coefficients. So you can take 3 minus 5, you can combine those. And instead of having separate, I combine them. So now I took 3 square root of 2i's from one group and I subtracted 5 square root of 2i's from another group. Together, I get negative 2 square root of 2i. Okay. So I hope that helps. Okay, so next example. let's try this one. Okay, so first things first, convert them, extract the I, right? So this simply becomes square root of 3 with the I outside, and then plus square root of 27 with the I outside as well. Okay, so now 27, well, 3 is simplified down to its lowest form, but 27 is not. So starting with 27, factor tree it. We can do 9 times 3. 27 no longer active, so now 9 times 3, we can factor down 9 into 3 times 3. 9 is no longer active, so cross it out. Okay, I'm looking for a pair, all right? So even though I have a triplet of 3s here, I only care for a pair. So there's one pair here. Unfortunately, this 3 gets left out. So then we can rewrite this as 3 square root of 3. Okay, so 27 is going to be 3 square root of 3i. And then I can drop the rest, square root of 3i. Okay, so now, remember what I said before. If they have the same, basically, if they have the same variable, I can add my coefficients. Now, in this case, I don't have a number in front of the square root of 3, right, for this first part. If I don't have a number there, I can at least put a 1. I have one of them. I have 1 square root of 3i. Okay, so now I want you to think of this square root of 3i, okay, as the variable, right? Do they have the same variable? Do they both have square root of 3i? Yes, they do, right? Yes, they do. So then, what am I allowed to do with these coefficients? I have a coefficient of 1 and a coefficient of 3. I'm allowed to bring those together. So 1 plus 3 is 4. And then I bring down the variable, right? The variable. I'm calling it a variable. It's not really a variable, but I'm bringing down what they have in common, which would be the square root of 3i. Okay? Is that a little bit more clear now? Does that help? All right. Okay, so let's move on, and now these last 2 examples, these will be the challenging ones. Okay, so let's go here to example 5. Okay, so we have square root of negative 3c squared plus square root of negative 27c squared minus square root of 45c squared. Okay. So in this case, because there's so much going on inside of each particular square root, I'm going to break these up. Okay, so I'm going to split this as the square root of 3, the square root of negative 3 times the square root of c squared. Okay, because I want you to see what happens to each part individually, right? The square root of c squared, well, we know that the square root and the square cancel, so that leaves us with just a c. The square root of negative 3, that we can turn into square root of 3i. Okay, so we have square root of 3 times I times c. Okay, that's what we simplified it down to be. Okay, now the middle one. Right, this is square root of negative 27 times square root of c squared. We know that square root of c squared is just going to give us a c. Here, right, we know that the square root of 27, or negative 27, will become square root of 27 times I, so times c. And then we did square root of 27 in the previous problem, right? We know that the square root of 27 is 3 root 3. So we can make that transition now. And we can call this 3 root 3 I c. Okay. Root 3 I times c. Okay. And then finally, this last one, I have minus root 45 times root c squared. Okay, so the square and the square root cancel. We can drop c. And then the only thing we need to do now is clean up the 45 because 45 is not in the simplest form. So 45 will give us 9 times 5. And then 9 becomes 3 times 3. So you get 3, which will get to go outside the root, 3 root 5. Okay, so we can rewrite this as minus 3 root 5 times c. Okay. So now bring this down. Okay. So let's go ahead and then clean up whatever we can. I want you to pay attention to two things. One of these numbers is real and 2 of them are imaginary, right? These right here, because they have I, make them imaginary numbers, which means you can only combine them with other imaginary numbers. This one is not imaginary, right? It has C, but it doesn't have I, making it a real number, okay? Now remember how numbers are supposed to look. It's supposed to be A plus BI, which means that the real number goes in the front. So we got to do a little bit of a transformation here. We got to bring the real number front, so that'll be negative 3 root 5 C, okay? C is just a variable that's tacked on, okay? So it's just a variable we have to deal with. Okay, so you bring it with you. Okay, now we have the 2 imaginary numbers. We can combine them, okay? Or at least let's bring them over for now. And then we will combine them after. Okay, so we can bring over the positive root 3 IC. Let me erase this. And then we have positive 3 root 3 IC. Okay, so now if they're both imaginary, can I combine them? Do they have like terms? Okay, do they have like terms? Okay, well let's go back. I want to think about what the coefficient would be for this first value here, for this first imaginary number. Okay, what is the coefficient in front of the square root? If there's no number there, I'm allowed to drop a 1, okay, meaning that there's only one square root of 3 IC, and I want to see if I can combine it with the other square root of 3 ICs. Okay, so let me go ahead. I'm going to check, right, because I know that these are my coefficients. I have a coefficient of 1, coefficient of 3. Okay, do they have the matching tail? Do they have a matching variable? Okay, remember that they have to have everything has to be the same. So do they all have square root of 3? Yes. Do they both have I? Yes. Do they both have C? Yes. Okay, so then because they all have the square root of 3 IC, I can then combine the 2 coefficients, the 1 and the 3, making it 4 root 3 IC. Okay? And then I can bring down the negative 3 root 5C. Alright, so then this would be our final number right there. Okay. Another way in which you might see it is typically if there is an additional variable that is not the imaginary. Yeah, let me actually erase this box because I don't like how it was written. Typically this variable here goes in between the coefficient and the root. Okay, so a lot of times you might see it as negative 3c root 5. Okay, and then you plus 4. They bring the c in between the coefficient and the root, so 4c root 3, and then they leave I at the very end. Okay, this is actually how I would prefer it, because you leave I at the very end as opposed to having C at the end. So then that represents the final complex number there. Okay. Okay. All right. How we doing? We're okay? Let me know if there's questions. drop them in the chat. Okay. All right, and then one last one, this last example right here. Okay, so example number 6, I believe. Yeah. So for example 6, we have square root of negative 25 a to the third minus the square root of negative 225 a to the third plus 20a root negative a. Okay, so again, we're going to break these up individually. Okay, so I'm going to split it up first as the square root of negative 25 times the square root of a to the third. Okay, now in this case, this becomes the square root of 25i, and the square root of 25 is just 5, so we get 5i. Now we have to deal with the square root of a to the third. Okay, so a little bit of scratch on the side here. A to the third is the same thing as a times a times a. Well, if you're square rooting, you're looking for a pair of 2. That means that you get to write one a outside, but then this a, that's the loner that gets boxed inside the root. Okay, so then this actually becomes a root a. But it's all part of the same product, remember? So then you got to drop it all the way down. Oh yeah, the creaking noise is my chair. So I'm sitting on my kitchen table, so it's a wooden chair, so it creaks a little bit. Okay, now you see, I don't like how this is written because I don't like I being in between the coefficient and the variable. I should be at the end. So I'm going to rewrite this as 5a root a and then I at the end. Okay, and I'm much happier with that. Okay, now let's move on to the next part. Okay, so now we have a minus square root of, and I'm going to break this up into negative 225 times the roots of a to the third. Okay, minus here, that'll be the square root of 225i. Okay, and we already know what the square root of a to the third is going to be. It's the same as what we already got before. So we can go ahead and just drop a root a. Okay, so all we have to do now is find what is the square root of 225. Well, that's a number that has a nice square root. Square root of 225 is actually 15. Okay, so we have minus 15i a root a. And again, I don't like where the I is positioned. The I should be at the end of the number. Okay, so we're just going to rearrange some stuff. So I'm going to drop it down. We have negative 15a root a and then I at the end. All right, cool, almost done. All right, now this last one, okay, pretty simple. I have plus 20a. Now check this out, this one is root of negative a. Here I can just make that transition. I can make the a positive, but because I have to remove the negative, now I just bring the I to the outside. Okay, so now you see that's 20a root ai. That's already pretty much in the same form as the other two numbers that we have down here. Okay, so I can just bring it down 20a root a I. Okay, now here's where identify your coefficients. You have a coefficient of 5, coefficient of negative 15, and a coefficient of positive 20. You can only combine them if they all have the same components. Okay, do they all have a? Do they all have square root of a? Do they all have I? Okay, so let's go through. They all have a, they all have square root of a, and they all have I as well. Okay, that means they all basically have the same variable. Okay, which means you're allowed to do what with the coefficients? Okay, you can combine them. So 5 minus 15 plus 20, right? Combine those coefficients together, that's going to give you a positive 10. Positive 10 what? Well, you drop the common variable, right? Drop the common variable, which is a root a I. Okay, so then that right there is our final. Okay, and then that's it. How are we doing? We feel okay? Any questions on today's lesson? Okay, that's pretty much all that I have for you guys in terms of examples. Feeling okay. That AQ was like, but okay. All right. So I think homework is uploaded. It might not be. Let me check. Okay. Actually, it's not. So I will actually upload it right now. All right. So homework 2 will be there. The solutions to homework 2 will be right underneath. Okay, so you can check your work. Am I okay? I am okay. I'm healthy so far. I haven't gotten sick. Hopefully it stays that way. Okay. So we'll see how things go. But take care of yourselves. Definitely make sure you get food if you need it. That might be one of the harder things to find though, because people usually go like really early in the morning, so by the time you go like later in the day, there's like nothing else. Yes, homework. Alan, yes, do it, please. Okay, practice. Okay, so it'll be there later. I'll actually upload it in about a couple minutes. All right, so if there's no questions for me, then I'm gonna go ahead and log off, and I'll see you guys on Friday. Okay, so Friday we'll start off with like same as we did today. We'll do some homework review if there's any questions, and then we'll move on with the lesson. Okay. All right, guys. Well, thanks for keeping the chat lively. I appreciate it. Interesting things. Don't forget to get sleep, people. All right. So I'll see you guys later. Okay. Have a good one.